Good morning, everyone. You are very welcome to our 7th and very last SliceNet webinar in this series anyway. Our webinar today is on 5G integrated multi-domain slicing-friendly infrastructure. It is presented by Navid Nikaein from Eurecom in France. My name is Louise Caffrey. I'm from RedZinc. We are a partner in the SliceNet project and we are based in Ireland. I will be your moderator today. So just to introduce Navid, Navid Nikaein is a professor in the Communication System Department at Eurecom, where he is leading a group on experimental 4G and 5G system research related to radio access, edge, and core networks, with a blend of communication, computing, and data analysis. He is also a board member and leading the development of the radio access layer of openairinterface.org, as well as coordinating the Mosaic 5G.io initiative, whose goal is to provide software-based 4G, 5G service delivery platforms. In the SliceNet project, Navid leads the work on 5G slice-friendly infrastructure, and he is an expert on this subject. The purpose of the webinar today is to present the technical achievements and innovations regarding the design and prototyping of 5G integrated multi-domain SliceNet infrastructure based on open source software platforms. We will have time for questions halfway through and at the end of the presentation today. I will keep an eye on the chat box, so if any of you wish to ask a question or make a comment, please feel free to type this into the chat box and I can bring it up at question time. But for now, let's sit back and listen as Navid takes us through his presentation. Thank you, Navid.
Thanks, John, for the introduction. Welcome to my webinar today. I'm going to talk to you about this 5G integrated multi-domain slicing friendly infrastructure, which reflects the activities we have been doing in work package 3 of SliceNet. And I hope you enjoy this presentation. So I just have a little word about the purpose of this webinar, which we plan to present and disseminate the Slice Network Package 3 on activities we have been doing to build the 5G slice-friendly infrastructure. And I don't need to go through the introduction of myself because I already have been introduced. So I just skipped and go to the agenda of this presentation. First, I will give a very brief introduction of the SliceNet and its objective. Then I give the requirement and challenges in building what we planned for 5G infrastructure. I present you the technical approach for design and prototyping, because this work package 3 has for objective not only to design, but also to prototype this 5G infrastructure and deliver this prototype to the other work packages where they can extend it to additional features like cognitive plane or plug and play control plane and so forth that you have been watching during the previous webinars. The technical achievement that we have obtained in this work package, the major innovations, and also what was the main industry vertical applications we implemented and we showcased in this work package. And also at the end, some questions and answers and some references. So I provided some acronyms for those may not be familiar with the terminology that we are using in SliceNet, but also more widely in a telecom domain. So we have API, CN, API is application programming interface. Let me go through the most important one. Like we have control plane, CP, multi-access edge computing, MEC, machine type communication, MTC, open virtual switching, OVS, plug and play. This is very important that we are going to see. PNP, RAN, radio access network as opposed to the core network, CN, SDK, software development kit, UP user plane, UPF user plane function, and XApp are the network control apps. I hope you can remember a few of these acronyms that we are going to use in this presentation. So just simple word about a SliceNet. A SliceNet, on the bottom of the figure here, you see that we have different network domains. We have the radio access network, edge network, core network. All of them, they are captured in different slices that we see across different planes. And then we have this plug and play slice control, which is a place where we could on the fly push a slice control function, which then be exposed through this one-stop API. And this is a way in a SliceNet to expose the high-level APIs to the verticals. So there is a multi-level abstraction that is happening from the infrastructure, which is on the bottom, up to this one-stop API, so such that the slice like verticals service providers could easily and in a unified manner control and monitor their slice. So today focus is really on the button, like this 5G integrated multi-domain slice-friendly infrastructure. So to provide the foundation of the infrastructure that is going to be used in the other work packages of the SliceNet, such that we could provide the required level of abstraction and provide what is required to this vertical application and service on the top. So if I summarize what I said just before, we want to establish a slice-friendly physical and virtual network infrastructure and provide an execution foundation for the upper layer. So once we establish this slice-friendly, you see that the slicing comes a lot of time in my presentations because the SliceNet is really about a slicing in a multi-domain, both from the physical but also virtual network infrastructure. And this foundation is going to provide an execution for the upper layers to perform three main tasks. One is the monitoring, the other one is control and coordination. Control comes also with the programming of the underlying network. The second objective is to design and prototype of a control plane to support network slicing. Why this is important? It is important because if we have this control plane, this is what we are going to expose to the higher layers, where we could use it to realize the required actions and control that we want to exercise on the underlying 5G infrastructure. So once we have this control plane, and then the last objective is to actually put in place the prototype of this 5G infrastructure, but tailored now to different use cases, like not a generic infrastructure, but an infrastructure that is going to support the considered use case that we have in the SliceNet. So for example, eHealth, that I'm going to talk about in this subsequent slide. So the requirement and challenges in terms of the slicing is that we have different network segments, like we have RAN, we have edge of the network, we have the core network. So we need to support the slicing in different domains, right? So domains, of course, it could be technology domain, network segment domain, or even administrative domain. Here, in our case, we focus at the beginning on the network domains. So provide this slicing in a more end-to-end manner. Provide different level of isolation and sharing. So this means that we are going to isolate some of the resources, share some of the resources, but more in a flexible manner across different verticals and providers in terms of resources, processing, and state, and also slice orchestrations over this multi-domain infrastructure. And another challenge for us was to be able to customize the deployment. So we have a generic infrastructure that we instantiate as a blueprint, but we wanted to also customize this deployment tailored to different use cases. So the considered use cases in SliceNet are the following. So we have a so-called e-health scenario, which is characterized by high data rate and low latency communication. It also has the mobility of the users being the ambulance, moving from one base station to another, one cell to another. And given that the slicing is going to be exercised, we need to make sure that the requirement of this slice is maintained and service continuity is maintained when the user is moving from one base station to another one. A smart grid, on the other hand, does not require high data rate. It requires, however, high availability, reliability, and ultra low latency. And this latency becomes a key factor in a smart grid. There is no mobility as such in this type of deployment, but providing latency is of very much importance. And a smart city, this is more characterized by the large number of devices that connected to the network, and supporting this large number of devices is also a challenge in our deployment. So the technical approach for design and prototyping is shown on our right-hand side figure. As I explained at the beginning in the general description of the SliceNet project, we have different domains, like we have considered RAN, edge, backhaul, core, and wide area network. And for radio access network and the core network, we reuse the open area interface software platform to deploy the network. For the edge, we used open virtual switching in order to be able to do the local breakout and implement the programmability in the user plane. As for the controllers, so you see that here each domain has its own associated controller. So we have one controller for the RAN domain, another for the edge, another for the backhaul, another for the core. For the RAN, make, and core, we used software from the Mosaic 5G to realize the controller of associated underlying infrastructure. And then on the green, what we see is the network intra and inter-domain slicing control. So the green is all about the control plane. And what we see, the first thing that we see is that is the first level of the abstraction that we see on the top of these adapters. So we see that we have a heterogeneity in terms of the adapters, and abstraction here, it comes to unify the interaction with these underlying adapters and underlying control. For instance, you could have different ways to do the slicing in the RAN versus the core network, but this is abstracted in this first level abstraction. So there is a unified way to send the control commands to these adapters such that the slicing could be done across different domains. Here, domains again is different network segment. And then we have a second level abstraction, which is technology agnostic, which provide the agnostic API. It's nothing to do with technology, but it provides a more high level APIs for the verticals. And here is where we could also have a flexibility in plug and play control plane. So as I said, we leverage the existing open source platform for the 5G infrastructure, not only on the stack like OpenAir and Mosaic 5G, but also on the deployment. We leverage Kubernetes, OpenStack, OVS, and the Docker. In terms of the methodology of the design and prototyping, we adopted the incremental methodology in a sense that we have first instantiated generic infrastructure blueprint, so something that is quite generic not necessarily associated with any use case. Then we identified the requirement of the target use case and incrementally customize the infrastructure for each target use case. This means the integration of the new component. For instance, it could be a new plug and play component that we add here, or add specific functionalities in the adapter, and validate if this is working in an end-to-end manner. So in terms of, let's say, overall software, as I said, we leverage open source platform, and there is a good community behind this platform, but also these are the reproducible platforms. So any partner inside the SliceNet or outside of the SliceNet could reproduce the blueprint and try to customize the infrastructure according to his or her use cases. And you see here that we have multi layers. On the blue layers, we have the whole infrastructure of the RAN and the core. Then on the second, we have the controllers of the radio access network and the edge and the core, and some applications like software development kits or adapters that are coming on the level of the store. Here, I'm going to present you the generic infrastructure blueprint that we considered in SliceNet. So this does not necessarily represent any specific use case. And then I'm going to show you how this generic is customized for instance, for the e-health scenario. So what we see here is that we have a user plane first on the bottom, and then the control plane on the top, the same as what we had in the SliceNet architecture. We also see different segments. We have the RAN here, edge in the middle, and the core on the right. We see that we have the base stations that are connected to certain runtime environment on the top of local to the base station, such that some local actions could be decided. There is also a flex and control protocol to edge applications providing radio APIs, such that a slice provider, slice owner could use this API to interact, to monitor or to control the base station. We also see the UPF function, user plane function, and we have a UPF API and with the associated controller, and we see all of them are unified through the SDK. So this SDK, if we map it to the SliceNet architecture, this reflects all the control plane, the abstractions that we have been doing, like first level abstraction, which is technology dependent, and the second level abstraction, which is technology agnostic abstraction, all reflected in the SDK. And edge applications would be those applications that are used by the or deployed by the verticals. So we see that here two APIs. One is associated to the base station, the other one associated to the UPF, and then we have the core network that is only residing on the control plane. And we see the CNCP, which is the control plane of the core network, because in our case, the user plane, everything goes through this UPF function. And we could bunch of applications that are running on different network segments. We have also some videos here of example deployment that could be interesting to see how this generic blueprint is instantiated for different usage. I would say at this stage, I just make a little break in case there are some questions from the audience, and then if there is no questions, we follow up. And this is basically on the left, what you see is the general generic architecture of SliceNet project.
Yeah, so just a couple of questions here for you, Navid. First of all, for the generic infrastructure blueprint, which sounds like a great achievement. How did you identify the requirements of the use cases? Did you try them over 4G first, or how did you practically go about it?
The generic let's say blueprint is kind of independent from the use case, but it has the communication, the foundation of the communication on the bottom, what you see here, the RAN, the core, the edge, the backhaul, and the wide area network. It has the connectivity because the assumptions here is that if the controller is able to provide the required level of the control and monitoring through the adapters to a SliceNet control plane, what is going to be customized, right, is not the infrastructure, but also the abstraction and the plug and play control, right? So we managed to provide the required level of the flexibility inside the communication infrastructure on the button, like for instance, providing the slice friendly infrastructure, like we could do a slicing in the RAN, we could exercise a slicing in the edge and the core network, and all of them are exposed to the SliceNet control plane. And then the customization comes on the green part. This is what we call the blueprint because it includes everything needed uh, for a use case to be realized.
Okay, very good. And then how is end-to-end slicing enabled in your 5G infrastructure?
This is also a good question. This is enabled through the abstraction. You see that if you want to exercise a slicing on one domain, right, uh, you have the associated controller. However, in a SliceNet, what is done is that through this multi-level abstraction, the slicing uh, is going to be translated according to the different controllers. So from the perspective of the vertical, they see only a unified way of slicing. They don't see all the complexity and all the heterogeneity of the underlying network. They only see a simple API of, let's say, create the slice in a downstream or upstream with these associated metrics, these associated capabilities, and these through these abstractions will be translated. So the complexity resides in these abstractions. So the vertical, they do not really see this complexity, but when it comes to this abstraction, it gets translated to specific language of the controller.
Okay, and maybe you've answered this already, but how can such an infrastructure be reproduced?
Um, so given that we already have the blueprint,
Blueprint.
and also given that the software is open source, right? And there are some tutorials and some videos. Uh, it's um, it's just a matter of getting the blueprint and instantiating the platform. Of course, we need some hardware platform, some PCs. We need also some software-defined radios to support the radio access network. And actually, in this slide, this deployment one and two shows to a very good extent the blueprint. So for those who really want to know what we call blueprint, they can actually go and check these videos. The blueprint is just a descriptor the describing the infrastructure. So the infrastructure could be as complicated as uh, a cloud infrastructure, uh, very big cloud infrastructure, or as minimal as few PCs interconnected to each other, and in each of them we deploy different network.
Okay, excellent. Thanks, Navid.
You're welcome.
Any more questions? And we'll take them at the end. Thank you very much.
Okay, so I shall continue then. So now we are going to see how we instantiated the eHealth leveraging this generic infrastructure. So the features we wanted to have in eHealth was local breakout. So we wanted to make sure that the traffic, the high priority traffic could break out from the switch, goes to the edge and gets served by the edge application. We wanted to have the slice mobility, so as I said before, when the ambulance is moving from one base station to another, we want to maintain the service continuity while retaining the uh, slice resources across multiple base station. We also wanted to have proactive handover, like um, determine which base station these high priority users must be handed over in order to sustain the QS QoE. And of course, QS QoE is also another requirement that we had. So this was the features we identified. We also identified a bunch of applications that needs to be developed and plugged such as we can enable this use case. And you see also on the infrastructure level, we have instantiated multiple base station here. At least we need two to demonstrate the use case. We also might need to have multiple switches here to differentiate the traffic across the high priority users and low priority users. But the rest, we see we don't have any specific applications running on the core network or any specific controllers on the base station. We only have all the edge applications deployed without having anything specific on the RAN or on the core. So rerouting or local breakout is one of the main features that is required here. Uh, the caching, so caching of certain traffic, content optimization. If, for instance, we are moving from one base station to another, whereby some of the resources are missing, then we need to optimize the content such that the QS is maintained. Monitoring all the events, like handover here is of a good example, and network control handover is when the network decides to hand over the users to another base station. This is actually different from user control handover, where the user triggers the handover. Here, the network is proactive, understands that this user is high priority, and push the commands to the user such that the users get handed over to the another base station. So this concept of the network control handover we showed in the SliceNet EUCNC demo. Uh, and there is a link here for those who are interested to see only these features. They can actually follow up the demo here. In terms of the uh, control plane to support slicing, the here we focus more on the radio access network, but similar type of slicing is also applied to the core network. So we have an application. That this application, from the vertical perspective, has some abstractions that, as I said, they are all goes to software development kit, and this SDK talks to the adapter. So the adapter is actually adapting the high level language of the verticals to the low level language of the controller. So it's adapting uh, the request to a controller specific language. So this X app is actually requesting, I want a slice with 5 megabit per second, or with this latency. This gets to the adapter. Adapter understand this and translate this to uh, language of the controller, and sends the create or modify a slice with a specific QS parameters, which goes to the slice manager inside the base station, and use the RAN API to create the slice in a RAN data plane. The extensive set of APIs that we have been using for slicing, it can be looked over using these two links that we have provided. And on the left side, this figure that we show, it basically shows that the slicing is happening over an update window of W, where the resources are partitioned among different slices in a more dynamic manner. So the customization of the network slice in runtime is happening, as I said, through these adapters. These adapters allows to customize the network slice in runtime without breaking the service continuity. So the service is running, we customize the slices, and this customization, I have to mention that happens asymmetrically in downlink and uplink, in downstream and upstream. So one slice could have certain customizations for downlink and certain other customization in the uplink. And RAN adapters here are the key, because RAN adapters belongs to the SliceNet control plane, whereas the controller belongs to the control plane of the infrastructure. So there is here a decoupling of the control plane that is really technology dependent, whereas control plane that has an abstraction to the SliceNet control plane. And these adapters, as you see, they are exposing the control plane services of the RAN, edge, and the core network. So if I want to summarize at this stage the technical achievement we obtained throughout the project, I can mention three things. The first is a reproducible, slice-friendly infrastructure blueprint leveraging open source platforms. So this reproducible means that we can just take the software platforms, set up the hardware infrastructure, use the blueprint, and deploy the infrastructure, the generic infrastructure on the hardware infrastructure we have been setting up. And this uh, we have few examples of this blueprint that could be used. There are some videos that linked in this presentation that could be used by the partners to reproduce. The second achievement is related to the design and prototyping of the consolidated control plane. So this consolidated control plane means that we have different domains, we have different control planes, and each control plane works on different domain. And when we consolidate them, it means we unified them. We unified them through the abstraction levels that I showed you in the SliceNet architecture. We consolidate and unify this control plane. Also, we customize through the plug and play framework, whereas a vertical could easily, with a single API, uh, exercise monitoring, control, and programming on the underlying network infrastructure. We also have developed different programmable user planes. So we have one example we showed here is the OVS, but we have other FPGA based or hardware based programmable user plane. And the third one is the open interfaces and the API definitions for the RAN, edge, and core. In the previous slide, I showed you the link for the API. So these APIs are basically very important because it describes the language that we could talk to the radio access network, the language we can talk to the core network. And once we have that language, we could build on the top different abstractions like we did through the adapters or like we did through the SDK, such that verticals could easily interact with the underlying language, underlying infrastructure. So I can say that these APIs and open interfaces are the means for a SliceNet to realize the abstractions. So the industry, in terms of industry vertical application and the contribution, so we have shown that we have common components for different use cases, and this could be extended to additional use cases. We showed that for the vertical application, having a software-defined 4G, 5G infrastructure is of essence because this allows the programmability of the infrastructure. And the example of the X apps that we showed, like a local breakout, traffic redirections, changing the slicing configurations in terms of the priority, but also QS, uh, but also this proactive network control handover. Yeah. To summarize the innovation in this specific work package 3, we could highlight that one of the innovations goes to this reproducible SliceNet 4G, 5G infrastructure blueprint. So this blueprint for us is quite important because it simplifies the deployment of the infrastructure, provided that it supports the network slicing and programmable user plane, for which different use cases could be instantiated. And the second innovations goes to the definition of the interfaces and the API for different segment of the network and through multi-level abstractions, allowing to verticals to exercise the control and monitoring. So this is a way, through these interfaces and API, is a way to customize the network in runtime while maintaining the service continuity. So there are a lot of references that might be helpful for a better understanding of the work that has been carried out in this work package. In terms of the software component, we have the link to the radio access network of OpenAir that we have used for the core network. And in Mosaic 5G also there are different controllers that we use, but also the adapters we developed, they are also available if someone wants to reuse the adapters that have been developed. And all of those are explained in the deliverables. So we have produced 4 deliverables in work package 3. And you see here the links, and they all could be downloaded on the SliceNet website. And there is one deliverable in work package 4 that is confidential. And if someone is interested, this could be requested from the SliceNet coordinator, and maybe you can get a copy under NDA. So thanks for your listening to this webinar. I hope you enjoyed the presentation, although I try to focus more on the high level of the achievements. In case you have any questions or any details you would like to have, you can ask it right now, or even through emails. I would be happy to answer your questions. So thank you.
Thanks very much to Professor Navid Nikaein. We have some questions, and the first question is, on the multi-level abstraction, can it support other use cases, or was it customized for the 3 that you spoke about, eHealth, Smart City, and Smart Grid?
Yeah, to be fair, I would say, let me go back to here. So what we actually realized inside the adapters was those that were interest for our use case. We didn't develop all the abstractions. So I would say for the moment, we only support uh, the use cases in a SliceNet, but the, to develop, to extend the adapters is quite straightforward and easy. So we just need to translate the underlying control commands to something that is understandable by the SliceNet control plane. So today, uh, the adapters are developed for the considered use case, but to extend them to additional use case, we need to first identify, as I said before, let me go here, first identify what are the requirements of the target use case we want to realize in the blueprint, and then incrementally customize the adapter. Even maybe we need to customize some of the functions in the SliceNet. Maybe we need to add a new features here that we have not been considering in SliceNet. So I would say the today, uh, if we want to showcase another use case with new features, we really need to identify the requirement.
Okay, very good, thank you. Um, Another question then on the interfaces you mentioned in technical achievements and elsewhere, and the APIs. Will these will the work done in SliceNet make network standards specifications? Will service providers be obliged to offer these types of standards in their networks in the future?
This would be uh, great if we could leverage at least the lesson learned from the API specification and open interfaces inside the SliceNet. Today, ORAN is one of the main consortium trying to specify such interfaces, right? They are doing a very good job in the area of the 5G. So our hope is that they can at least leverage the lesson learned and some of the APIs that we have showcased, right? Um, uh, this basically depends on how could we reach out to ORAN consortium and how we could basically present the work that is done in a SliceNet and convince them that some of these APIs could be reused, not exactly in the same form, but at least the idea of those APIs could be leveraged in ORAN in the form of a new API that is more adequate to the ORAN specification.
Okay, great. And how would a vertical get hold of an interface or an API in order to have runtime network slices? What would the process be?
The process, let me go actually to the very high level picture of SliceNet here. So we see that in a SliceNet, once we go through different level of abstraction and we have this plug and play slice control, there is this one-stop API. So one-stop API, as it is seen here, is kind of unifying all the multi-level abstraction that we have been discussing previously. Like we have the first level, which really on the level of the domain controller. The second, which goes to the abstraction, which is technology dependent abstraction. Then we have this other level, which is technology agnostic, and it comes to the one-stop API. One-stop API is a set of high-level APIs exposed to the verticals. Let me give an example. It could be that a vertical says, I want a slice with 30 nodes, and I want to make sure that I have 5 megabit anytime guaranteed. So this is really high level, right? It doesn't describe how much resources do we need. It doesn't describe how the RAN and core should be configured to provision those users on the fly, right? So this is an abstraction. So the slice owner doesn't see all the complexity of uh, creating and programming the slice in a multi-domain environment. It just see simple request that says, I want this, and this will be when we cross this multi-level abstraction, it will be translated to different language of different domain and different actions.
Okay, and then there's one last question here. What are the main challenges when deploying an operational 5G infrastructure?
The first thing that comes to my mind is the challenges of network planning and also radio planning, because a lot of issues come from the fact that the radio environment is not adequate, or it is not what the users are expecting. So I would say radio engineering to have a very good network planning, making sure that the interference, making sure that the radio channel is properly uh, is working properly. This is one main challenge. The other challenge, I would say, with the softwareization of network component, We just need to have enough resources in terms of compute, networking, and processing, such that these softwares, which are requesting a lot of resources in real time, could be satisfied. Then the this would be really in terms of the deployment of the operational network, like engineering and planning properly the network, the radio part, right? Interconnection, provisioning the infrastructure properly, deploying the software, uh, and then yeah, I would say that, yes.
Okay, great. There aren't any other questions. So if we're all okay, thank you so much to Professor Nikaein for his excellent presentation today. We've learned a great deal about slice-friendly infrastructure and integration, and thanks for telling us about the technical achievements and innovation achieved. As we can see, SliceNet has met many challenging requirements of network slicing to help verticals achieve demanding use cases such as the ones we've heard about today. So we will close the presentation now. And we will put up the recording on our SliceNet website so you can see it again there. And this is the end of the series of webinars that we have presented on SliceNet. Thank you all for all of the presentations to date in SliceNet, and thank you to all of the people who have attended and registered and are interested. And thank you for listening.